This is a tutorial for the module Indices Maximus. Indices Maximus is the upgraded version of increasing indices, the cruel version if you will. Both modules are about solving polynomials, with Indices Maximus having polynomials up to the degree of 8. To solve the module, you need to input numbers that, when x equals that number, the output will be 0. So let's start. Let's go over to our calculator. If you know how to solve equations to this power, then you probably won't need the calculator, but I doubt that you do, or have the time to. So we're just going to use text field and input the equation right now. Now, since x is not a variable in this calculator, we're going to declare the variable, and we're just going to put it at 0. So the controls, we have a display. We have 4 buttons. This button, first you need to select something in the middle. You can, on the first stage, you cannot select the right button, so let's select the left button. Using the arrow buttons, it will change the number. This will create a fraction that is equivalent to a whole number, so -4 over 1 is just going to be -4. The left side is the numerator and the right side is the denominator. The top 4 displays will show the answers you've put in, and these 2 dots on the right show the stage you are on. So, first, we need to just brute force everything. So, we're going to start with -9, go to -8, -7, -6, -5, -4. Now, when x equals -4, the output to this equation is going to be 0. So first, we want to go to our number, and then press the display again. Now, let's do this again. 0 is a valid number, so we're going to go to 0 and click the display. We're going to go up now. 5 is a valid solution, so we're going to go to 5 and input. And 9 is a valid solution. Now, that was the first stage. On the second stage, these numbers are going to increase to maybe have a bigger coefficient or have more terms. But now you will notice on the second stage, you can select the right number, and this will allow us to change our denominator. You cannot go past -1 for. You cannot go past 1 for the denominator, because first you can't divide by 0, and also you won't need it because you can also just change the numerator to be negative to get your negative number. So we're just going to type this again. And we're going to brute force it again. This time, we have a denominator. Now first, since we're just going to start with the whole numbers, which means the denominator is 1. So we're going to start off with -9 divided by 1. This is not a valid solution. Let's go up. -2 over 1 is a valid solution, so we're going to input that. 3 over 1 is a valid solution. Now, I also want to say 3 over 1 is the same as 9 over 3 because they're different ways of expressing the same equation. So if you were trying to submit this, it wouldn't accept that because it doesn't strike you. You'll notice that it doesn't strike you. If you input numbers that are equivalent to other ones but are not the simplest form, you won't get striked. But if I were to put something in like 8-3, that doesn't make the equation equal 0, so we would get striked. This would be technically wrong, but we have grace. So we're going to input 3 over 1. Now we're going to just try this again for the other 2. since we've ran out of all the numbers, we're going to move on to the next denominator, which is divided by 2. And you'll notice that I'm going to be skipping evens because, or multiples of 2, because they are equivalent. For example, 4 over 2 is going to be equal to 2 over 1, so I'm just going to skip them because we don't need them. You can do this. See, 9 over 3, I forgot to skip 9 because that's a multiple of 3. We're going to go on to negative 4. Oops. Negative 5 over 4 is going to be a valid solution, so we're going to input that. And we have one more, so and 5 over 4 is going to be a valid solution. And that's the module solved. Notice you can use things like Wolfram Alpha if you want, but it's kind of, I believe it's not allowed by the challenge bomb rules if you're into that. But if we were to put this equation in Wolfram Alpha, we would get the same answers. Look, negative 2, 3, negative 5 over 4, and 5 over 4. Stay crazy.